Hi, welcome to my new video. Today I will try to explain the difference between the dataset returned by a query involving the wildcard path versus the query involving some static path which is not exploded, which doesn't contain any wildcard or aka glob expressions. So to demonstrate that case, I will use two different classes and of course the breakpoints added to the code. But before running the reading part, I have to generate some data. So the key part is this with column that adds some partitioning column to the dataset I'm going to write. And this column is very sample value, either A, B, or C, depending on how the number of the generation time. So next to it, I have two different scenarios. So I'm trying to use the data source v2 API. And in these two scenarios, the single difference is this path, this input path. For the first scenario, I will use the exact path for the data I generated. So you can see that I have these values. So we can find here the partitions. And for the second one, I will use this path plus the wildcard expression. And before diving deep into the execution details, I will show you the generated data frames. And you will see that there is one subtle, but maybe quite important to you, difference. The first part with wildcard, you can see that we have 4 columns currently, 3 main data columns, plus the partition column. Now when I'm going to run this code with wildcard path, you are going to see something completely different. You will see that we only have 3 input columns. Why that? So let me run this code in the debug mode right now and explain to you the moment making this difference or impacting this difference. So that's the first step. We are checking from the file table API whether we can, what are the base files, the root paths for the dataset. And here we have only this single path, because remember we are not using the wildcard expression, so Spark doesn't go into a kind of recursive ready. And now in the next step, Spark tries to get the data schema, so the schema of the data frame. And in this method, it has to infer the partitioning because we haven't defined it in this in the input parameters. And now in this infer partitioning method, there is something interesting, most exactly in this parse partitions, where we have something else. So we have the paths that represents generally all the subdirectories of the base path. And now check this out. We have the parse partitions. So there's something very interesting. Let me show you this part. I will see that the partition values will contain something. And this something comes from this infer partition column. And more exactly, it's not this place, it's this next one. Yes, it's the next place. So look at this. We have the base paths that corresponds to our input path. For the case of no wildcard query, we have only one path. And we also have the path. So the path that comes, remember we got 3 subdirectories of this input path and with the partition values. And later Spark analyzes these paths one by one and checks whether the base path contains the current path. If it's the case, it doesn't consider it as a partition value. Otherwise, it tries to parse this path and extract the partition column with the partition value. You can see that here it extracted correctly the partition value with the type, with the partition column with corresponding value, which is A. Now we already have this path, and we can stop the iteration, and Spark will continue this process for each of the previously resolved subdirectories. And that way, the partition spec will be defined. You can see that we have a column and we have also some values to this partition. So that was the reason for the no wildcard query. And let's see now what happens for the query with the wildcard based path. So here there will be something different. I'm sure that after my previous explanation you will see that immediately, just on the way. So we are in the parse partitions, date formatter partition, we parse each partition, and yeah, you can see that this time we don't have a single base path, because remember previously we defined only a static path without this wildcard. Here Spark analyzed this wildcard, exploded it into multiple values, and these multiple values makes that when we iterate here, each time we fall in this base path contains statement case situation, and as a consequence we don't try to parse the partition column from this exact path. And that's the reason why I can see what, although we have this partition value here, it's not considered as a partition column. So the same happens for B and the same happens for C. And that way the partition values are empty. So maybe I can see it later. Yes, I will see it here. And you can see that paths with partition values are empty, and despite the paths we had to analyze here contain this partition value. To sum up, be aware of that and try to adapt your path to your query logic. So for my case, probably I'm doing on sample show. I couldn't matter about this partition column present or missing in the output data frame. On the other hand, if you want to, for example, maybe propagate this partition information elsewhere or use the same partitioning schema on other data stores, well, in that case, maybe it could be interesting to fetch this information directly as a part of your data frame. And of course, as usual, there is a blog post which is linked just below in the description of this video, where you can find other details of this feature. And if you want to discover other articles about Apache Spark data engineering and cloud data engineering, I invite you to follow the blog or this YouTube channel, even though I put more content on the blog, and this YouTube channel is more to illustrate some of my examples. It was Bartosz Konieczny from waitlistforcode.com. Thanks for watching.